Afternoon class. Today what I'd like to do is to do an introductory video on the periodic table and the stories that go along with how elements are named. So as you can see, I have a set of elements, of 9 elements in the blue, the green, and the red section. I'm using them sort of color-coded to say, to declare how easy it is to pick up the rules for how to name certain elements and some of the rules that go along with how scientists have named the elements on the periodic table. What will happen in future videos is all the exceptions to these rules, all the places where the rules really break down, and that will be future videos. But for this one, it's mostly to explain how the elements get named and get their atomic symbol. So we'll start with the blue section because I declared this blue being the easiest section. So you got elements that are very common and very important for things like life and most common chemical processes. You've got something like hydrogen. So it's given by a single letter. So that letter defines the entirety of that, that element's name. Once you've given that, you then have to move on to, you can't just use hydrogen anymore. Now you can't use H for anything else, it's one element. So what you would do then is you would go into the next letter of the element, which is exactly what they did with helium, right? So H for hydrogen because it's the most common and abundant element. The next most common element, helium, but since H was already taken, they went to the second letter, E. And so on and so forth with all of those H names. Then we come to something like hafnium over here, and it's like HF. Now why would that be? Why wouldn't you use HA? And while I can't be sure about this, one of the reasons I think is to also help you as like a little mnemonic device to help you remember, think about and remember and make this atomic symbol distinct. And so that's why F is in there, because there are not that many times when H would be paired with F, to make an atomic symbol. And that's why when you see something with hafnium, you would say, oh yeah, HF sounds like hafnium. There's a little mnemonic device that goes on to help you remember. And so that is the rule, that's one of the rules that you can use to figure out how each of the elements is named, or at least how their atomic symbol is named. And this also falls fairly true with this green section, things like carbon, calcium, and cesium. So with carbon, it's the backbone of all life on Earth. So of course, in this one, we're going to use the letter C, just one letter C for carbon. But calcium is very important as well. I mean, it makes some of the hardest materials in biology. So why would that not be C? Well, because carbon is important to all life processes, it was given more importance. Calcium, on the other hand, Ca, so we just go straight to the second letter. That makes sense. Cesium, on the other hand, it's further down the periodic table, and also you want a way to remember it. So that's why it's another example of they take the third letter, they go past the E straight to the S and make you think, oh yeah, CS sounds like cesium. I can make this work, and it has that mnemonic device kind of thought process to it. Then there are, so blue section, green section, that works pretty nicely. Then there is the red section of elements, and again, I didn't do this based, meaning that they're harder or easier, or they're actual red, blue, and green sections on the periodic table. I didn't mean that. I just drew them to show you different ways of categorizing things. The other one is this with the aluminum, argon, and arsenic. There is no letter A for any of this, so this group would seem to be more of an exception to these rules. So one of the ways that you can think about it is this: there is no straight letter A that goes with any element, and the reason for that could potentially be because you've got aluminum and arsenic are two very ancient, well-known, well-discovered properties, and elements that have been found in nature for thousands of years. Long before we'd had the periodic table, long before we had anything resembling chemistry, people knew about these two materials. Possibly argon would have been found a little bit later, but still, arsenic, aluminum, very ancient names that were that predate all of modern chemistry. So these, to make them, and all, because they're all vitally important for civilization and how we run things on planet Earth, you can't say any one of them is like the basis for all other elements with that same letter in their name. So that's why they don't get those single letters like that. They start with like Al to make you think of, oh, aluminum, R for argon, and of course arsenic is AS. So it kind of follows that rule, except that in this one there is no straight letter A. But they, so these are the kind of normal rules that you might see throughout the periodic table. Most of the elements actually do follow this kind of trend in how they're named. But there are, of course, several exceptions to this, as I'm sure you can think of. So what I'm going to do in the next parts of this series of videos is to go over the story behind why certain elements are written in certain ways. Why don't they follow this system, essentially? So good luck in your studies, and we'll continue this next time.